Hello, everyone. My name is Gabriel Campos. I'm a solutions architect at Nexla. And today I'll be leading this workshop on how to customize AI models with proprietary and custom data. So today we're gonna embark on a detailed journey through the process of creating a sophisticated chatbot that is based on TripAdvisor reviews using retrieval-augmented generation, or RAG. Our agenda is structured to give you basically a comprehensive understanding of the process. So we'll start by exploring different Gen AI approaches, setting the stage for why we choose specific methods for our chatbot. Next, we'll delve into the technical necessities for building a RAG system, including the tools and technologies that will be used. We'll then walk through a detailed tutorial on how to set up a RAG workflow, breaking down each component and its role in the system. And following the tutorial, I'll demonstrate how the RAG workflow operates in real time and showcase the end product, which is a fully functional chatbot. Of course, throughout this session, feel free to submit your questions. We'll have a dedicated Q&A segment to address them, ensuring you leave with a clear understanding of how to implement these technologies in your own projects. First of all, when considering Gen AI approaches, it is essential to weigh the differences in cost, technical requirements, and also time to value. So starting with building a model from scratch, it is basically the most resource-intensive option because it requires significant investment, both financially and in terms of technical expertise. The process is basically complex and time-consuming, but also offers the highest degree of customization for specific needs that can't be addressed by other methods. And moving to model tuning, this approach balances between customization and resource investment because it's less costly than building a model, but still more expensive than simpler methods. So the technical lift is considerable, especially when incorporating techniques like parameter efficient fine-tuning, which allows you for significant model customization. And the time to value is slower compared to more straightforward methods, but it can be also very effective for specific applications. And finally, we have retrieval-augmented generation, or RAG, which presents both a cost-effective and time-efficient solution. It is by far the quickest way to add value with a relatively easy technical lift. This makes RAG an ideal choice for projects where speed and ease of implementation are key priorities, especially when working under tighter budget constraints. So given its efficiency and ease of use, we'll focus on the RAG approach. It's ideal for rapid deployment and adaptability, which we'll explore in depth in the following steps. So in the next part of our discussion, we'll unpack the essential components required to build an effective RAG workflow. Each component will play a critical role in ensuring the system functions seamlessly and efficiently. So we'll take a look at these key elements one by one. So first of all, let's talk about how we turn words into something a computer can understand. So this is where an embedding model comes in. It's basically like a translator that changes text into numbers. These numbers are not random. They represent the meaning and the context of words and phrases. So this diagram you see on your screen shows how words are turned into vectors. It's a bit like giving each word or phrase its unique code. And I like to think that vector embeddings are like digital fingerprints of words and phrases because they help the computer recognize what each word means. And this step is super important because it helps the system working with our language. If we were to do this with free text, it would be much harder and computationally heavy to process all this data. So now, after we've turned our words into these unique number codes, we need a special place to store them. And this is where a vector database comes in. It's like a high-tech library for all these number codes. And it's not just about storing them, but it's also about finding and matching them quickly and accurately. So the image on the left here, the green dots, gives us an idea of how the codes are stored. They're not just in a long list or a tabular format, but they're arranged in such a way that the system can make sense of how the data relate to each other. Like, for example, how books in a library are organized so you can easily find what you need at a glance. So taking a look at the second chart on the right, it shows how the database finds things that are similar. So for example, imagine you give it a picture of a cat, this green arrow right here. So the database not only finds other pictures of cats, but also things that are related to cats, such as the word meow, which is the sound that a cat makes. And it can even find things that are a bit similar, but not the same, like a dog or the word wolf. So it does this using a method called cosine similarity, which is basically a way of measuring how close or far apart these number codes are. And once we have the right information picked out by our vector database, it's time for the large language model to do its magic. It will take the information we found and use it to create responses that make sense and fit the context. These models will be basically the brain of our operation. They are really good at understanding language and generating replies that are not just accurate, but also sound natural to us. And what's special here is how the LLM doesn't work alone, because it's using information from our vector database to make its responses even better. This way, when the LLM generates a response, it's not only guessing, but it's using specific and relevant information to make its answers more informed and on point. This combination is basically what makes our chatbot smart and helpful. So now that we have our embedding model, a vector database, and our LLM, the critical task is to integrate and orchestrate these components effectively. In this process, it's not just about connecting these parts, but it's crucial that they communicate and share data seamlessly. So consider, for example, the journey of a user's query. All of the steps must occur within a few seconds to ensure we don't keep the user waiting for a response. So it's this rapid and efficient data exchange that makes a chatbot not only intelligent, but also responsive and user-friendly. While it is possible to write code or develop a standalone application for this integration, managing such a complex and time-sensitive process can be challenging. So to ensure this high level of efficiency and speed, we've chosen to use Nextlaw because it excels in handling these intricate data integrations and orchestration, which facilitates the smooth and rapid interplay between each component. This choice will basically allow us to focus on enhancing the chatbot's capabilities without the burden of complex or manual integration. So let's now walk through the retrieval-augmented generation, or RAG, process step by step. This will basically give us a clear understanding of how each component we discussed comes together to create our chatbot, right? So first of all, we need to prepare our data for the RAG system. It's not just about the initial setup, but also ensuring a continuous flow of updated information. So the first step in this ongoing process is ingesting free text into our vector database. We can do that by taking data from structured data sources, web pages, documents, anywhere. So, for example, if we take data from unstructured data from free text, we start by chunking the text by breaking it down into digestible, manageable pieces. Then each of these chunks is then transformed into a vector embedding, essentially giving each piece a unique digital identity, just like I mentioned before. And finally, we batch push these vectors into our vector database using its API. So the continuous updating of our database is especially crucial in contexts like we are building right now, such as a chatbot that responds based on TripAdvisor reviews. So imagine a user querying about the latest situation of a hotel or a tourist location. The system needs to reflect the most recent reviews and information. So by regularly refreshing our database with the latest TripAdvisor data, we ensure that the responses are not only accurate, but also timely. So it's this dynamic and current data flow that empowers our RAG system to deliver responses that are both relevant and also valuable to users seeking the latest information. Now, let's take a look at the RAG flow in action. So imagine a user poses a question to our chatbot, right? This query hits our webhook, which starts the process. The first step will be to enrich the context of this query. So the first thing we need to do is convert the user query into a vector embedding using the same vector embedding model that I mentioned in the beginning. So we turn the user query into a vector representation. Then this embedding is used to search our vector database for similar vectors, pulling out relevant metadata from the top K most similar vectors. And in this stage, we can also add real-time data from APIs, databases, any source, to enrich the context even further. So for example, in this scenario, we could say, we could enrich the context with TripAdvisor reviews, but we could also enrich the context with weather data from the user location, for example, to make sure that every recommendation is tailored to the weather forecast in the user location. So after we enriched the context, all this information is fed into our large language model, and the LLM will then process it and generate a response, which we send back to the user. The tricky part, again, is that this entire flow happens within a few seconds. So the conversation stays natural and it feels like you're talking to a human, but you're talking to a robot, which is basically performing all of these steps at once. So it's critical that this is orchestrated in a good way, right? So now that we've talked about how to build a chatbot, let's basically see how it's done. I'm going to show you the 3 Nextcloud data flow that make this all work. And this is where you really get to see how everything we've discussed comes together. And after that, I'll also show you a live demo of our chatbot, so you see how it answers questions in real time, just like it would if a customer was using it, very similar to what we have experienced with ChatGPT, for example, but for our own chatbot. So let me change my screen real quick to show you the data flows. Okay, here it is. Awesome. So right here, we have 3 different data flows. First of all, we need to ingest this data into Pinecone, which is our vector database of choice. So we've chosen Pinecone, we need to ingest data. So here we have TripAdvisor reviews on a CSV file. And here are some samples of this data. So it has the ID of the review, a rating up to 5 stars, and also the text for the review itself. So we know what the user was talking about. We then basically turn all of these reviews into vectors by querying the OpenAI endpoint for vector embeddings. So you can choose any vector embedding system or model that you'd like. Here in this case, in this example, we are using OpenAI's because it provides a straightforward API to do so. So basically what we're doing is we're generating a hash of the ID by hashing together the rating and the review. So we have a unique hash for each review. And then we grab the review and push it into OpenAI's vector embedding model, which will then return us with a vector embedding array. And as you can see here, we have a function that turns the text to a vector embedding by basically calling the OpenAI endpoint with an API key, the review text, and also the model that we want to use for this vector embedding, right? So after we've done all of this, we also need to build the payload in such a way that Pinecone accepts it. So basically, Pinecone expects us to send the values of the vector and also metadata. Because when you query Pinecone, it's going to return the top K vectors with their metadata. And we're looking for the metadata because the LLM will process the reviews themselves. The vectors are only used for querying the most similar reviews to our user query, for example. So we do have a payload which matches what Pinecone is expecting, which is composed by an ID, a metadata object with all the metadata that we want to push, and all the values for the vector embeddings for this review, right? So after we have the reviews with vector embeddings, we then need to push these vectors into Pinecone. So here we basically calling Pinecone API to upsert vectors in a batch fashion. So basically we're batching records 20 at a time because vectors are so huge. We would not want to throttle Pinecone API. So we batch them in 20s and we send them to Pinecone for an upsert operation, which basically is updating existing vectors and also inserting new vectors if they don't exist. So for example, if I had a review, but for some reason the user changed his mind about the hotel, something has gone wrong, then we can update what the user thought about the hotel in the vector database as well. So this is quite useful. So after we ingested everything to Pinecone, we do need to query this data somehow. So we do have another flow to query data from Pinecone. And Pinecone provides an endpoint to query data using a vector and some parameters such as the top K vectors that you want to retrieve. So for example, if I want to retrieve a big context, if I have plenty of tokens to spend on my LLM, maybe I can retrieve, I don't know, top 1,000 vectors, and this will give me big context to send to the LLM. But of course, it's flexible. So if you want to bring less context, you can choose to bring only the top 20 most similar vectors, and Pinecone will bring you this. This is standard for most of the vector databases. Most of them provide you with a way of querying the top K vectors, so it's mostly standard. And basically, here in Nexla, we do have a way of turning every data product into an API. So we have a canonical endpoint to query Pinecone within Nexla. And this is why we need this data flow, because then we can easily query Pinecone within other data flows. And this leads me to our third data flow, which is our RAG flow and our webhook that will receive user queries, process them, and then send responses back to the user. So we do have a webhook as a source. Then we, similarly to the TripAdvisor reviews, we do transform the user query into a vector embedding as well. So we get the user query, we then turn the user query into a vector embedding using the same vector embedding model, then using the internal Nexla mechanism that I just shown you, we query Pinecone for the similar 1,000 vectors to this query vector. And then Pinecone is going to return to me the top K reviews that are most similar to what the user asked. So for example, if the user asks something related to hotels in a specific location, probably Pinecone is going to return all of the reviews for this specific location. And then I'm going to grab only the reviews themselves and send that information with my query to the large language model. So in this step, we are basically turning the user query into a vector embedding, enriching the context with vector embeddings coming from the database. And then in the next step, we'll send all of this data to our LLM of choice. So here I basically call the OpenAI chat endpoint with the query, and also with the query enhancement string, which is basically an array of all the reviews that I retrieved from the vector database together to ask the LLM a question with my query. So in this case, we're using also OpenAI's LLM to perform the retrieval augmented generation, and specifically we're using GPT 3.5 Turbo. But as I previously mentioned, this is easily connected. You can connect it to any LLM or any source. It doesn't matter uh, your vector database nor your LLM. It's easily you can easily set it up for any LLM. So basically, these three data flows are the main. They compose the structure to our chatbot, and I will show that in a second. We do have a question, so let me read it for you. Assume structured JSON for a person where first name is foo, last name is bar. For reg, while populating my vector database, am I better off in embedding the structured data as is, or whether it works better with this record is for a person with first name foo and last name bar? Does it even matter? That's a good question. So for most LLMs out there, you can enrich the context beforehand, like with the fixed context. So for example, in this case, in our example, we've set up OpenAI's LLM in such a way that beforehand, we mentioned that the context that we'll give is basically TripAdvisor reviews. So before it gets the context, it already knows what to expect, because we previously mentioned what we're building and what it is going to retrieve from the vector database. So using your example, you could perform a prompt engineering kind of stuff where you previously mentioned that you're gonna give first and last name for a person, and then you're gonna perform queries on this data. You can, for example, provide JSON objects, complete JSON objects, and say, hey, I'm going to provide JSON objects for your context. Please take them before generating your response. So your LLM will be ready for these JSON objects because you've provided context about what they are. In other words, if I just like sent free text without saying it was from TripAdvisor reviews, OpenAI wouldn't know how to process this text. So yes, essentially you can work it either way, basically. But yeah, it's a very good question. Thank you. So now I think it's time for the live demo. So here you can see basically a front end to the webhook that we have on Nextla. This is basically done. It's a very simple front end. Was built with HTML, CSS, and JavaScript. 3 files only, super easy to set up. You could Dockerize it and deploy to any cloud service or even self-hosted, doesn't matter, because it's basically querying our webhook and getting responses back. So for example, I can ask, tell me what is a general complaint about hotels in San Francisco. And then this whole process happens where it's gonna, our webhook's gonna receive that, it's gonna turn that into a vector embedding, it's gonna reach the context, and then send to the LLM, and this is the response. So based on the TripAdvisor reviews, one common complaint about hotels in San Francisco is the high cost of accommodation. Many travelers mention that hotels in the city can be quite expensive compared to other destinations. Other complaints include limited parking options, small room sizes, and so on. So as you can see, it's completely enriched with the data that we have from TripAdvisor. For example, I'm from Brazil. I'm from São Paulo, Brazil. I can ask, what are some good locations to go to in São Paulo, Brazil during the holidays? Let's say, I don't know. And then same process happens again. As you can see, blazing fast. Within a few seconds, we were able to process all this stuff. And as you can see, there are several popular locations to visit in São Paulo. Ibirapuera Park. As a Brazilian, I can confirm that it's an awesome location. So this is coming from TripAdvisor reviews. This is the most up-to-date information that the user can have, and it's far easier than having to scroll through all the TripAdvisor reviews and look for information over there. So this is a much more friendlier interface to your users. And of course, you can apply it to anything. So for example, if you have internal company information, we always have these people where who we ask lots of questions to. So you could, for example, get all of your knowledge base articles, all of your ticketing stuff, or your internal Slack messages, ingest all of this stuff into a vector database, and then build a chatbot on top of that to make sure your employees have a straightforward way of asking questions and getting answers right away, like in just a few seconds, right? And as long as you keep Slack updated and your knowledge base updated, you don't need to worry about the data, because the vector database, of course, if you keep continuous integration flow, the database is going to be updated every time, so you have the most up-to-date information. So yeah, it's quite valuable to have such a tool right now. So yeah, this basically was the chatbot that we created. As I mentioned, it's fairly simple to do once you get to know the whole process. Most of the stuff that I've shown here, the tools, they provide a free trial, so you can have a trial on OpenAI, on Pinecone, and even using Nextla if you want. So you can start building this data flows right away and your application right away as well. Okay, so let me change my screen share again. Let's go back to the slides for a second. Okay. So now we have a dedicated Q&A session. I do think we had all the questions covered. If you have any more questions, I'll be happy to answer them. Yeah, I can also tell you a little bit more. Yeah, we have a question. So could you share the real-time weather impact on the responses provided? So yeah, we in this example, we didn't integrate with real-time weather, but we could do so because it would require, for example, it would require the front end to send location to the webhook, but it would be very easy to do so as well. It would be just a matter of getting the user coordinates and sending with the query itself, and making sure that on our orchestration flow, we had a way of querying weather data from an endpoint that gets, for example, coordinates as a parameter. So another question is, how do you know that the responses are always real and not hallucinations? That is a very good question. So it is a tricky question because this is model evaluation. So you would need to make a study yourself, like you need to experiment with the model to make sure that they're not hallucinations. You can do some sort of prompt engineering, and your LLM, most of the LLMs out there, for example, OpenAI, they provide several parameters that you can tweak to change, for example, the temperature of the LLM to make sure it doesn't get creative or it doesn't hallucinate, and it's based only on your data. In our example, as we quickly created a simple data flow, it is very easy to experiment. So for example, if I wanted to tweak the temperature a little bit to see if hallucinations get better or not, I could easily do it from the API parameters and test it right away. No need for like redeployment or restructuring stuff. So it's up to you. I mean, we have different ways of measuring that. And we have, like, for each LLM, it's different because we do have different parameters. But our approach is what makes it easy to do. Because if you were to like create your model from scratch, it's much harder to figure out what's going on. And even if you do, you would need to retrain the whole model. And this will take a while, not only computationally speaking, but also time effectively. Yeah. So can you summarize again the exact role of OpenAI? The data is the one you input in the CSV. There's no OpenAI data here for anything here, right? Yes, that's a very good question. So OpenAI here, in this example, we've used OpenAI, but you can use any vector embedding model as you want. For example, we have LangChain, we have Llama, we have different vendors, and you can have your own vector embedding model. But to make it clear, we could ingest the CSV text into a database, for example. The problem is we don't have a way to query similar things on a traditional database. We can query for text. So for example, if you're looking for a SQL database, if we query a varchar column, a string column, you need to query for the exact words. And that's the problem, because you don't know what to query. Because for specific things, you need to understand the concept around the review, not only the words themselves. So what the vector embedding model does is basically getting the text and transforming it into a numerical representation of like thousands of dimensions. And this representation basically can understand the context and the concept behind the text, and not only the words. So that's why we need it, because we need to query similar stuff, right? We need to query context, contextual data. And this is quite hard to do with traditional databases. That's why we need the OpenAI embedding model. And of course, in the end, we also need the large language model. It can be any vendor as well, to provide the responses, just like as we have on a chatbot. So the response is dynamically generated. So yeah. Okay, so if you want to provide links, resources along with responses, how does that work? That's an awesome question. It depends on your orchestration and integration part. So if you're using your own code, probably you'd like to like perform some web scraping on these pages to ingest data into the vector embedding model, and then finally push the vector embeddings into the vector database. But for example, using Nextla, we do have ways of automatically ingesting resources such as documents, HTML, like from different connectors. So we do have that out of the box. But if you're using your own code, you would need to transform these resources into text before using the vector embedding model. So keep that in mind. The vector embedding model only takes, it does, some vector embedding models takes images as well. They're very specific, but they can take images. But for example, for PDFs or PDF documents, they're not used to that. They only get text. So you would need to do that within your code before using the vector embedding model. And yeah, the other question was, I answered the two questions at once. Awesome. Okay. So yeah, in order to what do we do if the query exceeds the embedding model's token length? Yeah, so this we can manage it beforehand. So for example, if you're using your own code, you can make sure that the top K vectors are that they fit within your token length that your LLM is set to receive. You can also, for example, because you don't know beforehand the length of the reviews, right? So probably you would probably need a mechanism beforehand to make sure that the retrieved reviews from the vector database don't exceed the token length that your embedding model is expecting. And some of the embedding models also support this automatic token length verification, where it replies back to you saying token length exceeding, try again with more. Using Nextla, we do have ways of automatic retry. So for example, if we hit your vector embedding endpoint, and for some reason we exceeded the token length, we can perform another try with less data, and we can do this iteratively until we hit a good response. Basically, exponential backing off would be a good mechanism to implement here. Awesome. Thank you for your questions. They are very relevant. What considerations should one give to optimize response performance? That is a fantastic question. Uh, I mean, mainly you want the connectivity to your vector database and embedding model to be really quick. So you want to have low latencies for these two connections because like getting data from vector databases, because we get lots of data from it, it can be like network speaking, it can be very heavy. So you want to have a very stable and low latency connection to that resource. For example, if you're using self-hosted vector embedding models or vector databases, you want to keep them in the same network, in the same VPC if you're using a cloud service, for example. So you do want to make the to keep the latencies low. Using Nextcloud, for example, we do have synchronous requests to this, and we do have separate containers to make sure that these requests don't get messed up with other flows that you might be running. So we separate these to make sure that their performance is always high, so we get a quick response, just like as you saw on the live demo. But yeah, you want to make sure that they are in a good VM instance, and also with low latencies between them. Any more questions? Okay, so I think we can wrap up. I just wanted to also give you an overview on Nexla. So basically, Nexla was founded in 2016 based in San Mateo, and it has grown to a team of over 100 people. We focus on making data operations and machine learning more accessible and efficient. And we also recognize as a Gartner Cool vendor. We empower businesses with better data solutions. And on this slide, you'll see some of the major customers we've partnered with. And these partnerships reflect our commitment to addressing complex data challenges across various industries. And talking about like Gen AI specifically, Nextla stands out for its flexibility and adaptability regarding scaling Gen AI projects from early experimentation to full-scale enterprise deployment. So we can efficiently handle large-scale data ingestion, supporting diverse data formats and systems out of the box. And we also support multiple vector database, which basically allows for easy experimentation with different data storage, with different retrieval methods, and so on. And we also have the ability to enrich context with various real-time data sources, including APIs, relational databases, which basically will enable this rapid integration with many different services out of the box. And it will keep this latency low, just like as we had some question around that. And of course, as a unified tool for data and workflow integration, it also simplifies the process of experimenting with different configurations and setups. So you make sure that you have the best model to work with, you have the less hallucinations possible. So yeah, it's best if you can easily change, easily tweak, and easily experiment. And lastly, Nextla's multi-cloud capability allows for the integration of various AI models and cloud environments. And basically, it enables teams to experiment, compare models, choosing basically the best fit for their use case, whether vendor or self-hosted. So before closing the session, I must remind you that we will email you the slide deck and additional resources so you can easily get started with building your own RAG workflow. And I can answer one last question. OpenAI provides an easy way for RAG as well, GPT-4 based. How is that different from what's offered by Nexla? Isn't that easier? That's a good question. Nexla, basically OpenAI offers this mechanism, but it's not like, as I mentioned on the presentation, what is important is to orchestrate this continuous data flow to make sure your data is always up to date. And also, OpenAI doesn't support real-time retrieval of data, which Nexla supports. So for example, if you want to connect not only your vector database, in other words, not only your fixed data, but also several different sources of live data, I don't know, market, news, financial information, exchange rates, all at once, OpenAI doesn't support that. And in Nexla, you can use all of that in a single data flow to make sure that you have the best context ever to your responses, right? And if you're taking data from multiple sources, such as I mentioned on the internal company example, Slack, knowledge base, and I don't know, customer related documents, orchestrating all of these sources is not possible within OpenAI. So Nexla provides that. So that's where we play a good part in orchestrating this whole data flow, right? Okay, so thank you very much for all of you that are present. I hope you enjoyed the session, and I hope you also leave this session being able to build your first chatbot or your first RAG workflow. You can also get in touch with me if you have any additional questions. If you want to see a quick demo on Nexla, please feel free to reach out to me. This is my email, gabriel.campos@nexla.com. Thank you again, everyone, and have a nice day.